and that start. Wait. Okay. So this is working. Cool. Let me remove all this. Hi everyone. Okay, let's see if I'm able to arrange all of this so it makes sense. So we're gonna be working on the Advent of Code, adventofcode.com, and we're gonna be, let's see, log in. Gonna silence this. Wait, can I do this a little bit higher? Okay, that way I can read the messages but not see my face. And actually, GitHub, will that work? No. Twitter, will that work? And my password that you're not going to see because I'm cool. Okay, let's see if this works. Sí, hablo español. That didn't work. Let me see, do I have the other one? Actually that's already logged in there. So cool. So we're gonna be working on exercise number 5 and on. That's not how you write my name, not even close. But at the same time, I'll probably also misspell your name, Saikidan, so no hard feelings. Cool. So if you have not seen the previous episodes, maybe a little bit confusing, but I'm gonna keep working on my repository that I created for Advent of Code. It's already online, so you can find it on github.com/compose/adventofcode. You can go see the code and the solutions for the previous exercises. But we're gonna be working on day, so let's do day 05 part 1. I'm gonna copy the skeleton to day 01 part 5 part 1 as main.go and do open with Visual Studio Code. No worries. No hard feelings. I know my name is kind of weird. Okay, so cool. So we have everything that is ready here. I have a small skeleton just to read the file and iterate over it, but I may need to change it anyway. It's just like skeleton. Okay, so let's start with exercise number 5. Day number 5. Exercise actually number 9, I guess, because there's 2 exercises per day. 1, 2, 3, 4, 5. Yeah, 9. Okay, so alchemical reduction. I'm not sure how you pronounce it. But alchemical reduction. So if you've managed to sneak in to the prototype suit manufacturing lab, the elves are making decent progress but are still struggling with the suit's size reduction capabilities. Let me check. Am I using this mic? I think it's connected. Just in case, I'm gonna bring it closer because this might sound much better. Okay, so the very latest in 1518 alchemic. I really don't know how to pronounce alchemical. Let's ask Google. How do you pronounce alchemical?
Alchemical.
Okay, alchemical. So I was saying it correctly. Cool. So while the very latest in 1518 alchemical technology might have solved their problem eventually, you can do better. You scan the chemical composition of the suit's material and discover that it is formed by extremely long polymers, one of which is available as your puzzle input. The polymer is formed by smaller units which, when triggered, react with each other such that 2 adjacent units of the same type and opposite polarity are destroyed. React with each other such that 2 adjacent units of the same type and opposite polarity are destroyed, like matter and antimatter energy. Units types are represented by letters. Units polarity represented by capitalization. For instance, R and capital R are units with the same type but opposite polarity, whereas R and S are entirely different types and do not react. For example, A, lower A, capital A, and leave nothing behind. B react, and then A react, so destroy itself, okay, so leave nothing. A B, nothing reacts, right? So nothing happens. And A B, nothing reacts, yeah, because they're the same type, but so nothing reacts, it stays same. Okay, so now consider larger examples. The first CC is removed. Okay, so CC is removed. Why is CC here? Why is this CC and not the other CC? Either CC or CC are removed, the result is the same. Okay, so you can choose whatever. So let's do this here actually. I'm gonna create an input.text and just write there. Input.text. So that's gonna be, so this CC react. So now you get, those go away. Then A react. So that goes away. Then CC right here, react. So you end up with this. And then D, A, B, C, nothing else can react. So you end up with that. Is that the result? No further actions are being taken, and that corresponds to this. Yes, it does. After all possible reactions, the resulting polymer contains 10 units. How many units remain after full reacting the polymer you scan? Note, in this puzzle, notice the input is large. If you copy paste your input, make sure you get the whole thing. Cool. That's it. Oh yeah, it is long. That is a single string? Damn. Yeah, that's a single string. Okay, and the last character is very far away. Very, very far away. Thank you for the notification. That's not what I wanted. Wait, can I just go like this and... Visual Studio Code is not very... What does... Okay, so that I don't like. I wonder if it's cat input.text. Okay, so that finishes with R and X, and this finishes with R and X. That looks good. Visual Studio Code will cut the line after 10,000 columns. Okay, you should not be coding with 10,000 columns or more anyway. So okay, so we're gonna read the input, but since it's one line only, the scanner doesn't really make sense. So instead, I'm just gonna scan the whole string once. So that's gonna be IO util read file. That's gonna be our bytes, and then yeah, we can keep it like that. Or should we transform it to string? Let's transform it to string. So compute string of B. What do we need to return? So we need to return 10 units. So that is the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's the length. So let's call this simplify or react, and that's going to return the reaction, and we're gonna print the length of R. So now we just need to do the rest. So react given a string, returns another string. Cool. So I guess the way we could do is just iterate over the whole string a bunch of times until we don't find anything else, and then we just exit. So for exit, return S. And what we're going to do is every single time we're gonna go for I 0, I smaller than length of S, I plus plus. And I'm going to do this like this. It might not be the most efficient way. Let's try like this and see how it behaves and whether the program is correct. And then we'll see whether with the long input we still have the same issues or not. Actually, let's go back to the smaller input first. Let's make sure that this works with the initial one and then go from there. what is he making? I'm solving exercise number 5. No, exercise number 1, day 5. So trying to figure out, given a string, which is this one, every single time we find a lowercase and capital case same letter, we're going to remove them and we're gonna try to find how much we can simplify. I'm gonna start with the simplest solution. I like to do that and see how it behaves, because if it's fast enough, we're good. This contest is not about finding the fastest solution. It's about finding the fastest solution you can write, actually, I guess. So I'm good with this. Okay, so if actually let's go length -1. So that way, what I'm gonna do is check whether the next has something. I'm gonna return s in here, because if we finish the whole thing if we finish the whole iteration without finding anything, then it means that we cannot simplify anything else. So if if s of I opposites, if they're opposites, so if s of I and s of I plus 1 they're opposite, then we're going to do s equals s of up to I plus s I plus 2 and on, and then we're going to continue here, continue loop. This is kind of a weird way of writing it, but basically I want to continue the loop, but I want to continue not this, but rather I want to continue back to this one here. No, I don't like this. Let's write it. So step of s, and we're gonna do s and okay. So for okay, yeah, so what I'm gonna do is return s. So this will return okay as long as we find something that can be simplified, and s will be the next string. When okay is false, it means that we are done, we didn't find anything, and then we break the loop and return s. I think it is a little bit more elegant than the previous code. So s string and return string and boolean, and what we're gonna do is we're gonna iterate over the whole thing, and if we return this, we're gonna return this and true. Otherwise, we're gonna return s and false. And then now, so okay equals true. Why not use one loop and set it to -1 before we continue? I mean, there's many ways of doing it. I think that this is actually very simple to understand, and I'd rather write a little bit more code and be very clear on my intent, rather than ending up, because there's going to be many loops, and in general I feel like you end up always messing up. Opposite, so that's going to be A and B, which are, those are going to be bytes, and so that's going to be a boolean. We're going to return whether so const diff equals a minus a. I don't remember whether it's that direction or not. So if a plus diff equals b, so return, or a minus diff equals b. And this doesn't make any sense because this should be minus 32 overflows. Yeah, so b plus diff equals a. Is that are you happy with that? Constant minus 32. Oh, okay, so because this, okay, so this is actually the other way. So that is the difference between lowercase and uppercase, which is the difference all the time. And so if the difference between uppercase and lowercase is a, so let's write some tests. Main test.go. So okay, so package main, test opposite t testing.t, and we're going to run something there. So tt is going to be a struct, a b byte, and boolean. Okay, equal boolean, result boolean. Okay, and we're gonna say that a, so a and a is true. The opposite should also be true. If both are lowercase, that should be false. If they're simply different letters, that should be false too. Where are the likes to the video? I don't know. You go and like it. Go like the video, people. Can you like the video? I don't know. Maybe you cannot like the video. So if you cannot like the video, just wait till later and like it later. Okay, so that is gonna be a B. That seems like good enough, I'd say. So for tc range tt t dot run. Let's give a name. So we're gonna do character, and so that we're gonna pass tc.a, tc.b, and func testing.t. So that's gonna be our testing thing. And so we're gonna compare in here. It's gonna be if opposite of tc.a, tc.b is different to tc.res. So let's do res equals this, and res is different to tc.res. t.fatal f expected opposite of this and this to be this got this. So tc.a, tc.b, tc.res, and res. Cool. So then people go like the video. Okay, so let's try this. Run the test. Okay, so expected opposite of a and b to be true got false. A and b to be true got false. Yeah, that makes sense because this is false actually. So my test was wrong. Run test. Cool. So that looks good. So the opposite seems like a good idea. Also, this const will be computed only once. It's computed at compile time, so this should be okay. The variables in the naming in tests are actually the names I use all the time, TT and TC, because otherwise, so TT stands for test table, and TC stands for test case, and T stands for testing. And if I mix them, I always end up running, like shadowing one variable with another and messing it up. So that's why I always go with these names. If you see any of my code, you will see the test looking exactly the same all the time. And I think I got that from the Go standard library. So it might be, I think it feels idiomatic to me, at least. I might be wrong. Okay, so step. So let's try this. So step, it's right at test too, actually. So func test step t testing.t. So we're gonna do the same tt struct. We're gonna have in and out are strings, and okay is a boolean, and we're gonna have things like, let's get the input here. So actually, so if we got AA, we expect to get empty string and a true. AA, we should get the same, AA and false. Same for this, but that's not that interesting anymore. So let's say A, B, B, we should get BB and true. And if we get A, we should get A and true. Also, let's use the input from the problem, just for fun, and say this should return DABAC. This should return this is gone. Okay, so now for TC range TT, you see I do this all the time. T.run of actually you can use tc.in as the name, and function t.testing t, and here next we're going to say if step, so if out equals step of tc.in, out and okay. And yeah, so if tc.ok different okay, t.fatal f expected next expected okay to be something, got something else. So expect, actually let's do tc.errorf, so because that way we will also check the next step. So expect okay to be v, got b, so expected it to be tc okay, got okay, and then kind of the same, but we're gonna do, instead of okays, we're gonna do out. I expected out to be okay, got okay. By the way, that is, so when you do command capital D, no, that is debug. Ooh, I should not say those words in here. So command D will select the next one. That's why I select all of this, so that way you can change it for foo or whatever, or in our case, tc.out. That's a pretty useful thing to know. Okay, run the tests. And the result is okay, perfect. So now I have enough confidence to say that this is probably okay. So let's run the program. Go run main.go. 10. Cool. Let's print, so println s. I'm gonna print it here. So that looks good. That looks exactly as we expected. So what happens if now I use the real input? The big input. Run the program, and let's see. Okay, that's fast enough. So I'm not gonna try to find a better solution. I'm sure there's more efficient solutions, but at the end of the day, what I'm looking for is that one gold star. Cool, got it. So, cool. So any questions about this code? I think it's pretty straightforward. I like to separate things on logical units, so that's why I have the React step and opposite. But do you have any questions in there? And I know there's a lag, so I'll wait for a couple seconds. Nope. Okay, so let's continue. If you're still listening, please say hi in the chat or something. I feel like no one's there anymore. Okay, so let's git commit -m day 5 part 1, and now we're gonna do from day 5 to day 5 part 2 and part 2. Cool. No one's saying anything. Is still working? Let's see. Okay, good. Wow, that's a very long lag. Crazy. Okay, good to know that I'm not alone. Okay, so let's see the second part. Let's continue with part 2. Okay, so time to improve the polymer. One of the unit types is causing problems, preventing the polymer from collapsing as much as it should. Your goal is to figure out which unit type is causing the most problems. Remove all instances of it, regardless of polarity, fully react the remaining polymer, and measure its length. For example, again, using the polymer DA, whatever from above, removing all A units produces the DBCCC, whatever, fully reacting this polymer produces CBZ, which is length 6. Removing all polymers BB has length 8, okay. So since this one, removing C and C is the one that goes the lowest, that's the one we produce, and we answer with 4. So that's great because it means that we can keep basically all of the code. The only difference is that instead of React the string like this, what we're gonna do is, so let's see, so we should have a list of the things that we could do. So for okay, I'm going to update that. The delay is like 30 to 45 seconds. That's crazy. And you will hear that in 30 to 45 seconds. So I'm not gonna wait for your answer. Cool. So what we're gonna do is, let's see, we are going to find options. Is gonna be, so what was the name? Is it Polymer? It's one of the unit types. Okay, so let's call it units equals unit. So let's say units is a slice of bytes, actually a map of byte to boolean, because that's gonna be, I don't care about the order really, and I just want to have them all. So now what I'm gonna do is for I equals 0, I is more than length of s, I plus plus. I'm gonna do I feel like I wanna do it only once. So I wanna do only lowercase. If there's only uppercase, okay, so I'm gonna write this in a different function. Yeah, I don't know what to do with the delay, unfortunately. I think it's a YouTube thing. At least if the quality you're getting is good enough, that's something. Okay, so units of s, it's for. Alright, so let's write a function. Function units of s string. Can you work with channels? Yeah, but I don't think it makes any sense in this case. And I don't think it will make any sense in any of the prompts we've seen so far, to be honest. Okay, so this is gonna return a map for bonus challenge. No. Okay, so we're gonna return that. So we're gonna var units, and the first thing we're gonna do is strings to lower of s, because that way I can do u of s of I equals true, and return s, return u, close. Actually that should be u equals make a map. So then we can go and say for unit in that mean len equals let's start with -1, and then we're gonna do if you so r equals react of, okay, so we're gonna need to define as string of b. We're gonna do that only once, so that's gonna be s. And what we're gonna do is we're gonna react trim u. So if r smaller than min len, so if len of r is smaller than min len, then min len, if min len is smaller than 0, or the length of min len is this, then min len equals the length of r. And we're gonna print min len. And we need the trim function. Trim string and a byte. And that's gonna return a string. So what we're gonna do is we're gonna go for the not very performant way, but you know, who cares? So we're gonna do a string, yeah, let's just do that. So R is gonna be an empty string for I equals 0, I is more than length of S, I plus plus. Actually, I'm gonna do byte, and we're gonna return string of R. It's kind of a pain to go between bytes and strings like that, but if it works fast enough, I'm okay. And so if S of I if S of I, let's think about this for a second. So what I want to do is I want to remove it. So this is going to be lowercase for sure. So if S of I equals B, or S of I and just going to repeat that piece of code. So S of I plus diff equals B, then continue. Otherwise, R equals append R of S of I. And since this piece of code is a little bit more complicated, I'm going to add one more test. Func test trim t testing.t, and we're gonna do tt struct. So we're gonna say that there's gonna be in, out strings, and b or unit is gonna be a byte. So if we have something like a b b c c, and we pass, actually I prefer to say it like this, out string. So if we remove a, we should have BBCC. If we remove B, we have ACC. And if we remove C, we should have AABB. And for TC, range TT, if trim of tc.in, tc.u, so out equals this, and out is different to tc.out, t.fatal, expected trim to be this. Actually, let's add the quotes. Got this, and that's gonna be tc, so out, expected tc.out, and got out. Cool, let's run that test, and it passes. Cool, so I'm good. I don't know, I should stop writing tests. They pass anyway. Okay, so this seems like something correct. So let's try to run let's try to run it actually. Terminal, give me the terminal, remove this terminal, go run main.go. Ooh, cause that's the big input, right? I mean, I want to try it first. So let's see, with this input, it should return 4. 4. All right, so let's see whether that was right. So whether this is 4052. Yay, that was correct. Okay, MB count letters with look forward for next letter. MB count letters with look forward for next letter, and then how much you have in map. I think that what you're telling me is basically what units is doing, I think, but I'm not completely sure what you mean, Dolphy. Unfortunately, sorry about that. Cool, so yeah, basically the only thing we added was we add trim, so we can drop a given character from all of, actually, isn't there, I'm almost sure there's a string, there's a strings dot something, strings dot replace returns a copy of the string as with the first n non-overlapping instances of all replaced by new. If all is empty, it matches at the beginning of the string. Let's see the documentation. So now what am I trying to do? Golang.org package strings, and there's trim. And so if we do trim, why is this so complicated? Trim func. I don't want a trim func. I want trim. So this is trim hello and gophers, but if there's something in the middle, that will not remove it. Okay, so that is not trim that we want to do. I think it's replace. Replace, the function replace. This one here. Let's see what that works. So oink oink, really interesting. So if we do A, B, B, C, C, and we do A, and we remove this, that should remove A. And if we do this, okay, so that's actually, instead of trim, we can use this function. Because I feel like this function is kind of useless. So we can do is t equals string.replace of the string, and then we're gonna use, so this is gonna be sprintf c, and that's gonna be unit, and unit plus diff, and that should do the same. And there's a little bit less code, which is always nice. So we don't need to trim anymore. We just do pass t. What are you complaining about? Do you want more parameters? No. Diff is not defined, indeed. So diff is gonna be also here. Let's put it here. And that should still work. And return 4052. And I like this code because it uses the standard library a little bit better. Except that it's clearly wrong. So what does this print? Let's try that again in the. So if we do this, and we have sprintf c, and this is, so let's do a and a plus diff. That doesn't work at all. What is this? So that is the cut, and cut is gonna be this, and we're gonna print cut. C, A plus diff. Oh, because this could be actually A minus diff. I keep on mixing these things. Okay, so it's minus diff. So that's a minus. That way we have the uppercase. Let's run it again, and that should give 4052. Tin, tin, tin. Nope. What am I doing wrong? T, react T. If min-len. Do you see something wrong in this? Because I do not see it right now. Unit of S. Let's do it with a smaller input. That doesn't work. Interesting. Okay, so let's print S is S and T is T. You are using replace wrong, I think. Yeah, I agree. You, that will not print what I want. Yeah. String of you. Let's do that. So A. Why is this incorrect? Println cut. I know this should work. Println. So the cut is correct, and I'm using replace S with that. So when we remove DA, oh, I'm dumb, because this is trying to find AA. So this actually, if I had an A here by itself, that would not remove it. So that is the problem. That's what I thought. Oh, okay, so probably replace, maybe replace. Yeah, okay, so never mind. What we should probably do is remove all the printlns, because I know what's going on. We're gonna need to do a string of A, of U, and then T equals the same thing, string replace of that, U minus diff, and so that is one thing, that is the other thing, that is empty, and this kind of a pain, but so U minus diff, T react T, and this is still not correct. This should be at 4. So let's see. Println S printf. Okay, so S T U and T and break. So S U and T, and then we're gonna do U minus diff. So what is going on? Printf SCT 1 2 3 1 2 3. T is not happy with this. Oh, because I'm dumb. That's an S. Okay, so if we drop D, there was not D. Oh, because this capital D, but if we drop this, it prints this. So that looks good. If we drop A and A, okay, that is T. We'll get there, people. We'll get there. So that should be at T here, because that's what we're dropping. And now that prints a 4. Cool. Okay. So yeah, we're doing a string replace. First removing all of the lowercase and then uppercase. And yeah. Cool. So that is 4. And if we go back to the big input, that should be a little bit slower than before, but still give us the same number, which was 4,052. That's what we're looking for. 4,052. Cool. Okay. That's kind of a pain to write, but finally worked. So that's good. All right. So git add, git commit -m, day 5, part 2. Thank you, Steven. Very nice to say that. Just happy that people watch and we get to learn together. Cool. Okay, so that is done for day 5. So let's go to day 6. So day 6. Oh, that started to look like Santa Claus. So day 6. The device on your wrist beeps several times, and once again you feel like you're falling. Situation critical, the device announces. Destination indeterminate. Chronal interference detected. Please specify new target coordinates. The device then produces a list of coordinates, your puzzle input. Are they places it thinks are safe or dangerous? It recommends you check manual page 729. The elves did not give you a manual. Bad elves. If they're dangerous, maybe you can minimize the danger by finding the coordinate that gives the largest distance from the other points. I mean, that doesn't really make much sense, because if everything is really far away and like the only thing is really far away is just a pit with lions, bad move, but sure. So using only the Manhattan distance, which is like when you kind of block. So instead, if you have a one square of unit 1, rather than being the distance square of 2, it would be 1 plus 1, which is 2. That's how you basically Manhattan, because if you're walking in Manhattan, that's how much you get to walk. So using only the Manhattan distance, determine the area around each coordinate by counting the number of integer x, y locations that are closest to that coordinate and aren't tied in distance to any other coordinate. What? Using only the Manhattan distance, determine the area around each coordinate by counting the number of integer x, y locations that are closest to that coordinate and are tied in the like they're not at the same distance from a different point. Okay, your goal is to find the size of the largest area that isn't infinite. For example, consider the following list of coordinates: 1, 1, 1, 6, 8, 3, 8, 3, 4, 5, 5, 5, 5. So if we put it here, it looks like this. So F should be probably the one that's not farther away, because it's like 1, 2, 3, 1, 2, 3. So it's 1, 2, 3, 4. So 1, 2, 3, 1. Now, because there's gonna be, so this is 1, 2. Nice. So let's do this. Let's create day 6 part 1 and copy the skeleton. Copy the skeleton into day 6 part 1 main.go and open it again with day 6. Cool. So I'm gonna create already input.txt and stop playing with that here. Okay, so given this, here you would go something like, so this point is the closest, 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 this point is the closest. So I get A, because this is 1, 2. 1, 2. This is B, because 1, 2, this distance 2, well, here is 1, 2, 3. Okay. This one is 1, 2, 3, and here is 1, 2. So this is B. This is 1, 2, 3. So 1, 2, 3, 1, 2. So this is still A. Did you remove the test for the trim function? I did not. True. That's a good point. Let's do that real quick. So day 5 part 2. Wait. Day 5 part 2 main test.go. Let's remove all of this. Wait, I'm gonna do it. I'm gonna show that I actually know how to use Vim. So close. Okay, git add 5, day 5 part 2, git commit -m, removing and use test. Cool, thank you. I had totally forgotten about that. A, so that is A because it's 1, 2, so if we're here, we need to go 1, 2, 3. Here is 1, 2, 3, 4. This is 1, 2, 3. So all of these are B. Oh, so this is nothing because this is kind of complicated to draw. So I'm not gonna be drawing the whole thing. But the idea is that there's gonna be some areas around that are gonna be, so if you have the closest, actually probably we can write a program to do that. So let's create, we're gonna have a type that's gonna be type board, which is a struct that contains a bunch of positions, and those positions are gonna be a slice of bytes. And what we're gonna do is we're gonna read from that board. So var b, so b is a new board with, yeah, a new board. We could do var b board too, same thing. Okay, so now we're gonna, every single time we read something, actually let's move this into func read board, given a path, which is a string, it's going to return a board, a pointer to a board. And the path is going to be this path. And we're going to do b equals read board of input.text. Probably there's going to be an error there. So if error is no nil, log fatal error. Let's try to, write things a little bit better. Just gonna return the error here, and same here. We can probably just return the error too. Cool. So read board is read board of input, print the board. Read board, yeah, so that's gonna return a pointer to a board and an error. And that's gonna be nil and an error. That's gonna be nil and an error. Okay, a little bit more light. So this looks good. So now what we're gonna do is b is a pointer to board. And for each time you go through, so we're gonna be reading, the input's gonna be something like, actually that's not the input at all. The input is something like this. So the input's gonna be a point and a point. So we're going to do A, B are integers, and we're gonna do scanf for a number, comma, number. And then with scanf actually. scanf, and we're gonna pass, first goes s.text, d, a, and b. So now what we need to do is we need to go and paint let's make the board different. Actually, okay, so type position is gonna be a struct xy int, which is the position, and then a board is going to be a map of, let me make a map of let's think about this for a second. A map, yeah, I guess that it's going to be a map of struct, so a map of positions to what? To a letter. That's gonna be the character. Actually, yeah, sure, let's go with that. Because that returns, so yeah, so this is the whatever, and we need to return the size of the largest one. So we don't really care about the numbers, but we're gonna be giving it numbers because that's easier to follow. So, okay, so what we're gonna be doing here then is, let's give it a string name. I like that better. So instead of creating this, we're gonna do make board. And now what we're gonna do is for every time we go somewhere, we're gonna read a position, and we're gonna say that b of pos of a b equals a plus len This is ugly. Len of B as a string. This is really disgusting, people, but it should work. Type int does not support. Yeah, so instead of a wait, what type int does not support? So this as a card, as a byte. This is very, very ugly. Probably not a great idea. Type int does not support indexing. Pause literal. What are you talking about? Invalid operation, B position literal. Type int does not support indexing. Oh, because we shadowed the thing. Ugh. Alright, let's call it board too. That'd be a little bit bigger, but okay, so that's better. And we should return board. And then func b port string and let's print it. So we're going to find max, so max x max y equals 0 and 0, and for pause range range b, we're going to say if pause dot, so if, let's call it p, so if p dot x is bigger than max x, then max x equals p dot x. If, and let's do the same thing, if p dot y bigger than max y, then max y equals p dot y. And then for x equals 0, x smaller than max x, smaller or equal x plus plus, and for same thing. Oh, I was trying to use the for y max y, cool. We're going to print if, so n, okay, so name, and okay, ID, okay, it's gonna be b of pause x y. If not okay, print f. We need to create a string here. We're gonna create a string builder, actually. Let's use that. People don't know how to use it that well. Is it new builder? No, it's just builder, right? It's just struct. So bar builder, string builder, and so we're gonna do bar out. So we're gonna use sprintf out of dot and continue. Else f, so sprintf into out of id. Oh, and someone just got home, so I'm gonna have to interrupt the streaming. I might be back in a second. 1 second. Okay, I'm back. I can continue a little bit. So I'm gonna continue and finish this exercise and then go do something else, because after all, you know, it's Saturday. Cool, so let's see, we were here and then we're missing just sprint f, sprint should be okay. Sprint of and line and return out dot string. Px, oh, that is p, not o. Sprint, call not use, oh yeah, print, fprint actually. Fprint, because I'm printing that into, so printing into the builder. Okay, so now with this, we should have enough information to at least get the beginning of the program. So if I do go run main.go, cool. So now we're reading the thing and it corresponds to this. Oh no, we're missing F, right? A, B, C, D, E. A, B, C, D, E. A, B. It's not even the same order? That is interesting. So, oh, I see. Okay, so the way they're doing it is, so A, B, C, D, E. A, B, C, D, E. This doesn't make any sense. How is it that the naming, even if this code is A through F, the naming doesn't make any sense to me. 1, 1, 6, 1, 6. Oh, unless we are printing it backwards. So I think that this should be like this. Let's try just replacing that. A, B, C, D, E. A, B, C, D. Okay. And we're missing F. Apparently F was not happy. It needs one more spot at the end. No. So equals. Off by 1 mistakes all the time. Okay, so that looks better. Yeah, that's exactly. Oh, I saw your message less than, but I thought you were pointing to your own name. I was like, okay, cool. Yeah, okay, so now we have A, B, C, D, E, F, which corresponds to the same thing here. They're printing one more space, but there's no need for that, I'd say. I don't know why they're doing that, to be honest. Or how do you even know that they should print that? So the view is partial. The actual view extends infinitely in all directions using the Manhattan distance. Each location closest coordinate can be determined showing here in lowercase. So that looks cool. And what we can do is, so locations, in these examples, the area of coordinates A, B, C, and F are infinite. Yeah, because all of this is very far. So there's no other points. If there's no points that are smaller, either in X or Y, which happens for A, B, C, and F, right? A, B, C, and F, cool. Those are infinite, so we don't take them into account. Their areas extend forever outside the visible grid. However, the areas of coordinates D and E are finite because they're surrounded by the others. So D is closest to 9 locations and E is close to 17 locations, both including the coordinates locations itself. Okay, so what we could try to do, let's see how big is the puzzle input though. Okay, so the puzzle input is not huge. So what we can do is go per point and ask whether they're infinite or whether there's anything else. We can even drop all the infinite points, to be honest. So let's write some more code. So what I'm gonna do is, once I've read the thing, I'm gonna find finite equals b dot finite points, and b board finite points. It's gonna return a bunch of positions, slash of positions. Let's do that. Slice of positions. So for P in position in B, so those are all the positions. So F's, that's going to be our positions that are finite. So there's going to be a slice of positions. We're going to return Fs. And what we need to do is we need to check whether they are either the lowest X or the lowest Y. Is that how we do it? Because for instance, let's think about this for a second. This is the lowest X and lowest Y. This is the lowest X. So if they're on the same point, they're infinite. If this B was here, also one farther, it would not be neither max F nor max A. So eventually, it will get to a point where F is closer. Let's think about this for a little bit more. So if you have something like, it's a bunch of points. So you have, say, A here, and you have B here. The thing is that in this line, all of these points will be always closer to A than to B. Same here, and same here, but so let's make it so. So these three will be always closer to B. These three will be closer to A. These three will be exactly in the middle of the distance. So if we had this here though, basically what is gonna happen is, so 1, 2, 3, 1, 2, 3. Eventually the points are gonna be closer. You know what? Let's actually write a little bit of a program to help with this, because I'm not completely sure about the math behind this. So let's drop this, let's comment out this, and let's print the board with a little bit. So we're gonna print actually B dot closest of P. P being not of position XY. And let's print it. So B board closest position, P position, and we're gonna return a string. So ID equals something, distance equals -1 to start, and we're gonna say that for P, so for Q, range positions, range B, we're gonna go one after the other, and we're gonna compute the distance between P and Q. And let's see, so if the distance between 2 points, so actually what I should do is, this is gonna be a slice of strings. I'll show you why in a second. And distance is 0, we can do. We're not gonna be using the distance as much. So min equals 0. Let's do min equals -1, just in case. But now the interesting thing is that, so the distance between doesn't B contain all positions. No, B contains only the positions that we read. So that's why when we print, what we do is we find the minimum and the maximum, and we go step by step. And for every position, we print either a dot or something. And now what we're going to be doing is printing. But I don't think your math is correct. However, it should be sufficient to compute the distance between. Thank you for the feedback, but it's not very constructive. In what way it is not correct? Okay, so what I'm going to do is the distance between P and Q. So that's going to be D. If min, so if min is if min is less than 0, or min is more than D, D equals min, and IDs equals append IDs of B of Q. That should be the name. Return, okay, and continue. if they're not bigger, but if min is less than 0, we should simply say min equals d and IDs equals append IDs of b dot q, of q, and continue. So that is the first case. If not, if the minimum is, we need to replace this. So IDs is gonna be actually a slice of strings with it. We're gonna reset it. But if min equals d, then we're gonna do IDs equals append of IDs of b of q. And we're gonna return, so now if len of IDs equals 1, we return, so if len of IDs equals 1, we're gonna return IDs of 0. Else, we're gonna return a dot. Okay, so the idea here, and now we need the distance function. Dist pq, p and q, which are positions. We're gonna return an integer. We're gonna do the distance should be len, so return p of x minus q dot x math.abs of this, which just means that we need to do a float64 in order to work, plus math.abs of float64 of p dot y minus q dot y, and we're gonna do an int out of this. Not exactly. That's why I'm putting it in a function. Okay, so let's see when we run this. Actually, I want to return strings dot lower of this. That is totally wrong. It's amazingly wrong even. Line 81 has a typo. If min is, no, I don't think so. Because the idea here, let's actually debug it. So let's debug this. Open launch.json. Ooh, actually what I want to debug is actually a test, probably. No, I want to debug this, I think. Will that work? Check the, fail to continue. Debug console. Didn't say much. Wait. Oh, wait. Line 82. D equals min. Oh, shit. Yeah, indeed. That will make my program completely wrong. Yes. That looks much better. That looks much better. Okay, so does this look like what I expect? It looks quite similar at least, but let's compare it side to side. So this is one, and the output we got. So that is the output we expected. This is the output we got. That looks exactly the same. Yeah. Not exactly the same. This is different. Oh, because we're printing one position less, so this is actually fine. This would be C dot FFF. So that's good. Cool. So now my question is, if we change the input to say we have 1 1 and 1 3. And so that should print, these are both infinite, and that goes all the way. How can I make it to print something Let's actually make this so at least it prints 100 positions. It's a little bit too much. Let's say 50. Okay, so yeah, so you see this line here? That is what I mean by infinite, right? Like this line is creating two different sections, both are infinite. But my question is, if this point was indeed instead 2, 3, so it's a little bit forward, whether this would change. And this would still not change. Interesting, because it would still be, so the distance would always be, so even if I move this to 3, 3, yeah, this creates two areas. So, I just want to make sure that the ones we drop make sense. Because what I'm trying to decide basically is, if we go back to the previous input and we run this, and the interesting area is here, right? So this is going to be infinite. This is going to be infinite because E and F is here. Let's think about this. Since the distance, let's go back to 0 and 0. So since the distance is computed as the difference, so since the distance is computed as the difference, if I'm gonna need to do some mathing here. So distance of x p to q equals, so the distance to p to q for, okay, so given point x, distance to p to x equals distance to q to x, if distance, so if p dot x minus, let's call it different, let's call it z. No, p for position, no, I already taken that. So z. So px minus z dot x abs of this plus abs of p dot y minus z dot y equals abs of p dot q dot x z dot x plus abs of q dot y minus z dot y. So the idea here is, if we switch this around, we can find some kind of formula, I hope, where we have all of the y's on one side, all of the x on the other side. And the problem is the absolute's gonna make it hard, but so everything on the edges are infinite, sure, but the problem is, how do you define an edge, right? Like, does that mean that, I'm trying to figure out here is, what I'm trying to figure out is, for instance, if you have F is right here, right? And you have E is infinite. Now, E is not infinite because F is both larger on X and on Y. that's not how it works, because A is 1, 1, and it's also infinite, right? So that is, of course, no, that's not the answer, Sergey. Unfortunately, that'd be cool, but that's not. I don't think that is the answer. I think that the answer is, if the max and so if both x and y are larger, then it covers. But if x or y are bigger, so here, if we go back to that A and B, see if, okay, so I guess that the interesting input is going to be, we have 2, 2, so 3, 3, and 5, 5. 3 is finite because it only covers this here, and A and C are infinite. But if this was here, then B is now not finite, because we're gonna have, oh no, that's not what I wanted to do actually. I wanted to do 5, 3, but I mean, it's kind of the same thing. This is now infinite because it's gonna be moving all this way, and also all this way. So a point is covered by others only if they're both bigger in x and y. So the finite points are those for which so finite points are those for which, for Q range B, if P equals Q, continue. Otherwise, how do we do this? So if it's larger, the area that you see is only a part. It's actually infinite. So that's why I cannot do 0, because there's actually -1 and -2 and -3, and I can do max because it's also max plus 1. So yeah, no, it will not cut it, unfortunately. So what I need to do is finite points. So if P, let's see, it's probably okay, so I'm gonna do var min x, min y, max x, max y, and these are gonna be booleans. So actually, and these are gonna be booleans, and it's gonna be, actually I'm gonna set them to true, 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 and true. And what we're gonna do is we're gonna look at every point and see whether, actually this is not needed, because we're gonna look whether if P dot X so if P dot X is larger than Q dot X, and so if there's a point that has, yeah, okay, so I think that this should be correct. If P dot X is so if there's a point for which P dot X is more than Q dot X, then this is false. If P dot X is smaller than Q dot X, then max X is false. If P dot Y is bigger than P dot Y, min dot Y is false. And if P dot Y is smaller than Q dot Y, then this is false. So now we know whether there's any point that is actually bigger. So if min x or min y or max x or max y, then, so if those are, that means that those are infinite. So actually what we should do is n, or actually let's do this, like if not any of these, wait, what, here, whoops, if it's none of the minimum nor maximum, then it means that it's surrounded by points, which means that it is a finite point. So we're gonna do pen f's of p and return f's. Woo! Okay, so now let's try to run this. So for now, let's just get the finite points, and for f range finite, print f, print ln. That's not printing anything. Interesting. Let's do it step by step. So p, is this, okay, so 1 1 by, okay, so that is a good example. So println p lost min x to q. So we're gonna do v printf p q this and this. So that's gonna be lost max x, lost min y, lost max y. So 1 1, lost max x to, so max x, max y. Yeah, so it's, but it's still min, so min is true. So okay, this condition is wrong. So if it's min, no, that's actually, no, wait, yeah, so that's good. It lost max x and max y, but it never lost min x, min y, because it's the smallest one, therefore it's an infinite point, so it's not added here. 5 3, okay, so that's the thing. Here in this input there's none, but if we do 3 3, you should pwn 3 3. So 3 3 lost min x to 1 1, lost min, yeah, lost max s, lost max y, therefore it is good, right? So why print it? So min x, max x, min y, print f is finite. You don't like the lag. I don't like the lag either, unfortunately. But I don't know what to do. I think that maybe Twitch is better for this, but I don't know. So let's do p. So 3 3 is finite. Cool. But why is this not printing it here now? So when we do this, println f. Oh, because it's the range. Ah, dumb. Okay, that's, so this should print a 3. 3 3. Cool. Okay, so now we have the finite points. So all of those that might be candidates to be correct ones. So let's comment this out. And so they should just print now 3 3. 1 1. So where am I doing print? Okay, we don't need to print this either. 3 3 is the only candidate. So therefore, if there's only one candidate, we know that's the one. But if not, what we need to do is find your input always infinite. Yes, Sergey, you should go read this one. So advent of code. For those missing context on what I'm up to. Cool, so now what I want to do next is go and find all the inputs, so find the area around those. So I mean, yeah, so max area equals 0. So we're gonna go over all the finite points and if b dot area of f area is this, if area is more than max area, then max area equals A. And then I'm gonna print the max area. We're almost there. We just need now one more method. I feel like this is correct. We'll clean that later. So B board area for P pos, and that's gonna be an integer too. So what we need to do is we're gonna need to go around, and actually we can use probably the same thing, this same max, like these coordinates. Let's move it to func b board max coordinates, and that's gonna be returning an integer, and that's gonna be return max x, max y. Actually, let's do max pos, and that's gonna return a pos, and it's gonna return a pos of this. So that way we can do max equals b dot max pos, and this max y, it's gonna be max dot y, and it's gonna be max dot x. And then we can reuse that same max pos in here in our function. So max equals b dot max pos, and we're gonna go for I equals 0, I for x, max dot x, for y, max dot y, count byte of lowercase letters. Since you already have string, be lazy and count byte of lowercase letter. That's not a bad idea, actually. Yeah, that's actually not a bad idea at all, because what I'm doing is basically very similar. But I'm gonna be a little bit less lazy than that, because I wanna, eventually I want people to be able to understand the solution without having to read string. But you are totally right. Okay, so area equals 0, and return A. So if, and for Q equals range of B, so wait. Let's see what I did here, because that was pretty smart. Oh, B dot closest. So P. Okay, so what we're gonna do is if B dot closest of pos xy, if C equals P, A plus plus. Mismatch step string and okay, so if B of P equals. Alright, so now we print this and it says 0. So close though. So this should return 1, 2, 3, 4, 5, 6, 7. Why is this not happy? Because this is gonna be probably, let's see. So let's print pos and C. Type xy, pos of xy and C. Let's print that. So why is this not happy? Closest. So 3 is B. Oh, because lowercase. Yes, you're totally right. So C strings to upper. to upper. This is kind of ugly, but if we make it work, you know. Okay, 7. It returns a 7. And is that what we expect? So 1, 2, 3, 4, 5, 6, 7. Cool. So now let's make this a little bit less messy. Let's remove all of this printf that we're not using. So this, and whoa. This. All of these lines are going to disappear. This could be a switch statement instead. So let's try to do this like this. So case and this, and that's gonna be a switch. Then it's a little bit easier to follow like this. And also, is it possible to do more than one at a time? Oh, it is actually possible, right? Because we could do if p dot x, yeah, no. That's not correct. That is not a correct transformation. We need to keep those if, because you can do more than one at a time. This could be done into one though. Because you know that if it's smaller, it's bigger, it can be smaller. So okay, that's a little bit more compact. The closest. Okay, so that looks good. So now let's try to see whether with the initial input, which was this one, we get what we want, which is 17. Probably we should not be printing the board anymore. So here we should not be printing this board anymore. So they should print only 17, which is the number. Cool. And now we're gonna get the big input, put it there, run it, and see whether this finishes. And it's probably like cubic or something. Like the complexity of this algorithm is way higher than it should. But again, if this works, you know, we're good. So cool. No, that's not the right answer. Your answer is too high. Interesting. Well, that makes it hard because, I mean, if this is correct, 17, let's see. Let's print the board. Whoa, that's big. Ooh. Okay, so new line at end of input. Yeah, that's already there. No, but that's fine. Is it fine? I think it's fine. I don't think that changes anything because, oh yeah, because there's a 0, 0. But I don't think it changes anything, right? That's what I said. That yeah, no, it was the same input, so that's not the problem. We are going to change the way the strings work and start from. Oh yeah, there's enough that you cannot even name them anymore. That is cruel. Okay, so let's see. How are we going to debug this? Or.text. That is a really big output. Kind of looks cool though. You can see the map. This is actually kind of cool. Alright, so that, I mean, I would say that this looks good. So what if we did, let's try this thing. Okay, so I think that the problem might be actually in the way we're using the string. I think the problem might be the fact that we are doing ugly things with the strings. I don't think it's off by one error. I think the problem is that the way we created the board, this string, since we are transforming that into a letter, and then we are checking for the two upper. And if we have enough of them, actually we'll end up with a point that is also named A, because there's so many points. Is that possible? We have 50, so let's do this. So if I go for I equals 0, I smaller or equal to 50, I plus plus, and I do print string of A plus char byte of I. Yeah, so you see the problem is that the IDs are kind of messing this up, because when we're gonna be comparing A and lowercase a, we're gonna compare them and think they're the same. So let's stop doing that. I think that might be the problem. So instead I'm gonna use, instead of an integer, a string, I'm gonna use an integer now. Let's see where it fails. So this is gonna be, instead, it's just gonna be the length of the board. And so what we're gonna compare now is, so ID is gonna be int also. It's gonna be an int. It's gonna be strings to lower. Nope. Instead, we're gonna just return the integer. So just to make sure, actually, yeah, so that's gonna be the ID, and we're gonna use 0, so there's gonna be -1. Okay, so if we do this, closest now returns something a little bit different, but when we print the string, we're gonna do, when we call closest, we're gonna print F and do, so if C is more than 0, we're gonna be doing printf of, we're gonna do actually A, yeah, A plus byte of C, and we're gonna do that as a string, because that would, and we're never gonna go lowercase, so it will be actually different. So all the points near A will be A. Also, all the points near capital A will be capital A rather than lowercase a. And so else we're gonna print dot. We're gonna keep that. And there's gonna be one more mistake in here, which is okay. So let's see. Actually, let's do it with the previous input, with the easy input. Input. Well, easy. That input on the example, which is here. So 2 and 3. Let's see. let's see. So, okay, so the ID there is also wrong. So that should be. So that is, if not okay, closest. Okay, so that should print A and C small equal. Okay, so now we get something that kind of makes sense as before, and that returns 17. And if we do it with a long input, let's not print that board because there's no need for that. That should return something that's not 11,000. 9626. Okay. So now we do that, 9626, let's try that. That's not the right answer. Your answer is too high. Let's see. Wow, this is harder than I expected. So why could that be? Let's print the board again and return. And do the print to the board. So the board now, the shape it has is T's and U's and F's and J's. Are we getting the character equals dot? How are we comparing this? Max area, unreachable code. Yeah, that's fine. So closest returns the ID. So if the ID equals -1, okay, so this seems okay to me. Because that returns something that it looks pretty good. Is the distance, so if the distance is equal, so if the closest distance is less than 0, we just say, okay, this is the one you're going to be using. We could also just simply do, actually these are exactly the same, so let's put them together. So yeah, they should still do the same. The closest returns the IDs of 0 if the length is 0, otherwise returns -1. We know that there's going to be also at least 1 point, so that should be okay. The distance is well defined. I'd say the finite points might be wrong. I don't know. Area. But no, because if it's maybe the finite points is wrong and that's why we return such a big value. Let's see. That doesn't make any sense. Alright, we broke something there. Ooh, this is hard. Alright, let's see. The max pos, max x, max y, max x, max y. This looks correct to me. We are going to, are we doing this? Is this the number? But that's gonna just give a larger number, so let's see. Okay, if we remove the return. No, that seems wrong. It's printing many points. That cannot be correct, is it? Let's see. No, that's not the right answer. It's too low, yeah. I mean, there's a way of solving this, which is actually just giving numbers and finding finding the point, do a search, a binary search, and just find that because it tells you whether it's higher or lower. So, but that's kind of cheating. So let's not do that. Let's see. So every yeah, that's what I've done. For every position, minus 1000 to 1000. Why minus 1000 to 1000 though? So that's the closest. I think there might be a bug because I feel like this program is actually you should replace the slice, not append it. So if it's equal, I should not. Oh yes. Okay, that is indeed. This should be replaced like this. And okay, so that should be replaced. Okay, that looks better already. So 90. Yeah. Okay, so that is the first same result as before, which was not correct. Any ID on the bounding box meaning 1000 to 1000 are infinite. I don't know what you mean, sorry. Okay, so string looks good. And if we print it to the output, to the board, kind of create this cool map. And basically what we need to do here is now find which one has the bigger area of all of this. Now the problem is that this area is actually quite large and there's many different points. So let's see what we should do. There has to be a bug somewhere. Also, you need to do minus and plus. You cannot just do 0 to change the font size. Let's see. Finite points. So which are the finite points in this case? Let's see. Oh, I feel like this is going to be wrong. The finite points are going to be wrong. Let's try this. Println of f. So I can get the points that are supposed to be finite. There's too many of them, are there? What if you also input the ID of the biggest area so you can see if you're choosing the correct area? Yeah, sure. I can add this struggling git push origin master. So you can check it out if you want to. The code is github.com/compose/advent of code 2018. Okay, so let's see. So those points, are those points the correct ones? And which points are not finite in that case? Because we're getting, basically all of the points are finite, and that seems wrong. Yeah, I understood what you meant. Oh wait, what if you also output the ID of the biggest area so you can see if you're choosing the correct area? What if you also output the ID of the biggest area? So if you, oh yeah, okay, I can do that. So basically what you mean is max ID equals -1, I'd say -1, yeah. And max ID equals F. That is not the ID, that is the position. So let's do max pos, var max pos is a pos, and max pos. So we're gonna print max pos and max area. Nope, that's not one way to do. Go run main.go. And that's telling us that we're printing the point 114.78. 114.78. 114.78, which is 15. So that corresponds to so I 15 corresponds to P. So we are choosing this area here. Wait, these are, yeah, this area here. And that is totally wrong because this is not an infinite point. So that's the problem. The finite points is wrong. That is the problem. The good idea though. Thanks Pepito Trueno. Great name by the way. Yeah, so the problem is that this is an infinite area. So this is wrong. How can we know whether an area is infinite? I would say that you could probably count as like if you are on the if you reach the edge, probably you're infinite, but I'm not completely sure about that. Yeah, that's maybe let's see. One second. Let's see. I don't think that that P. So I don't think that just reaching the area is enough. So reaching the edge is enough. I think that the right algorithm should be. Let's see. There has to be some math. Like that is the thing. This function that decides whether a point is finite or not is wrong. So this should be. Let's think about the board. So this is infinite because the point, no matter where it is, there's something else. Okay, let's see. Gonna try to fix this, and if not, I'm gonna need to go. So the point should be. Any ideas on this one? This is kind of hard one. We could say that, let's see, if we reach outside and you're still getting that area, but let's think about this. So we have, what if 2 points have the same x, for example? This is not handled. If they have the same x, then is this, you're telling me I have a off by 1 in every single thing I wrote? That is possible. Let's see. No, because now it's even bigger. So now it's, the input is 143.43, which is 12, which corresponds to M. And if we search M here, let's see whether this is a decent area or not. Now again, we have the same problem. I think the problem is the diagonals. The diagonals are wrong, because if you have a diagonal there, you should have something else. So let's see if it has the minimum. So let's think about this condition for a second. So if it's not the minimum, so if it's not the minimum and not the maximum and not, so no, but this seems right to me. Okay, so I'm gonna have to go. So I'm gonna break it here, unless you have any other ideas. Any ideas on how to find which one are infinite? And I think it has to be something related to like the distance between A and B is the A, so A minus B dot X, and this is the abs of this, plus abs of A dot Y minus B dot Y. So, oh, the else's? Okay, I see where you're going. Is that a different result? No, it still returns exactly the same. Let's think about this. So, that is the distance. So, given a point P, so something is infinite if something is infinite if it's not surrounded by points, right? If you P range P, oh yeah, if P equals Q, continue. True, I'm actually adding everyone otherwise. that was dumb. Okay. 9626, we still know that is not correct. And according to this, so 114.78 is 15, which corresponds to letter P, which is the one we were seeing before, which is definitely infinite because it continues here. So no, that is still not correct. But let's think for a second before changing just all the code all the time. Let's think about what this means. A point is infinite if it's not surrounded. And a point is surrounded, point P is surrounded if for any axis X and Y, there's a larger, if there's 4 points that are larger X. Okay, so actually, if P is surrounded if there are 4 points, A, B, C, and D, for which A is larger, A dot X larger than P dot X, and A dot Y is larger than P dot Y. B, smaller and smaller. C larger and smaller, and D smaller and larger. We need to have those 4 points, and then it means that it's surrounded. So it's actually not this, but instead, so there's 4 booleans, but so let's do, so let's name them like this: x, y. So that is smaller and smaller, xy, xy, and xy, which are booleans, and we need to find them. So if p dot x smaller is larger than q dot x, and p dot y is larger than q dot y, then we're gonna say that we found x, y, because this one is smaller in every way. So this is true. If this is bigger, but this is smaller than x, y, right? So x is, the q dot x is smaller, but q dot y is bigger. This is true. If this is smaller, but this is bigger, it's gonna be xy. And this is smaller, and this is smaller than xy. And now the condition is gonna be if xy and xy and xy and xy, then that. Okay, so simple geometric math. You're funny. Okay, so let's see what this says now. Okay, this looks much better. So 225.99, 225.99, which is 48. 48 corresponds to lowercase q, and in the board we're gonna be finding it right there, and that is definitely finite. So I'm starting to get excited because it will mean that actually we got it right, and yes! Oh my god, that was hard. Okay, so let's clear it up a little bit. Yeah, saying that out loud is kind of funny. So these can definitely not be more than one at a time. So this can definitely be replaced with a case something and removing this. So switch, and since we're not comparing for equals, this is not necessary. Switch case. Let's see if this still returns the same thing. Cool. The distance looks good. The area looks good. String is not necessary, but I'm gonna keep it there. And we're good. So I'm just gonna add git commit day 6 part 1. Oh my god, that was hard. That was hard. And git push origin master, so you can check it out. And I'm out. This was way harder than I expected, but lucky it worked. So you can find all of the code already online. And if you have any questions, just file an issue or get in touch with Twitter and everything. I think the most important thing here is, you need to actually I'm gonna comment this here. Because this was the key thing was so returns so finite points returns all points that are not that are surrounded by other points. And this is the thing, and that is the thing. So probably if I had thought before I started writing code, I would have finished much faster. So lesson of the day is think before you write the code. The sum docs. Okay, so see you all and thanks for watching. Alright, bye friends. What? How did I go up? Cool. OBS and goodbye.